Hello viewers, let me quickly introduce myself before proceeding with the training videos for PMI-ACP. I am Vinayak Agarwal. I am a PMP, PMI-ACP and an ITIL certified IT professional with an experience of more than a decade now in the field of business analysis, project management and agile methodologies. In this session, that is module number 7, I will be cultivating you with the product quality. A rapid briefing of the topics which I will be covering today for you are quality management, cost of quality, that is COQ, frequent verification and validation techniques, test driven development TDD, CI continuous integration. We will talk about definition of done, that is DOD, Agile Acceptance Criteria, followed by feedback techniques for product, and continuous improvement process, that is CIP. We will talk about PDCA Cycle, balance, scorecard, Six Sigma DMAIC. Then we will move to Kaizen approach, Kanban, flow and cadence, and finally we will end the session with few tools for continuous improvement.
So before talking about product quality in Scrum, let's talk about what exactly is the definition of quality. So for quality, what do you understand? By term quality, it's the fitness for use of purpose, to do a right thing at right time, or maybe even at right place, to do a right thing at the right time, find and know what customer exactly wants, features that meet consumer needs and give customer probably a satisfaction level. Then conformation to standards and freedom from deficiencies or defects. Another part could be value or worthiness for money, etc. So these all parameters will generally talk about as an element of quality. And when we talk about the quality, then definitely we need to manage it accordingly in our project, so that we have a project quality management, which includes the processes, activities of the performing organization that determine quality policies, objectives, responsibilities, so that the project will satisfy the needs for which it was undertaken. So probably a product or a service with a happy customer, or maybe with the exactly what the customer wants, you have delivered it on time with the high product efficiency, or maybe any other component which you mark as a parameter or a dimension for your definition for quality. Moving on to the next slide, we have cost of quality. So what exactly is the term cost of quality, or which will be acronym as COQ? So cost of quality is equals to cost of control plus cost of failure of control. So what exactly these terms means? So when we talk about cost of control, it again is a combination of prevention cost plus the appraisal cost. We will discuss these terms in depth in the same slide. And when we talk about the cost of failure of control, again it includes an addition of two components, which is internal failure cost and also moreover external failure cost. So by the term prevention cost, what exactly are the prevention costs? So the cost which include to prevent the bad quality. So you can say the trainings, document processes, equipments, time to do it right. So all these parameters club into prevention costs. And appraisal costs are testing, destructive testing, loss, inspections or audits. Then when we talk about internal failure cost, it is rework, scrap. So let's distinguish, draw a line in between the cost of conformance and cost of non-conformance. So when we talk about prevention cost and appraisal cost, simply remember these are the money or the cost spent during the project to avoid failure. So a kind of, suppose let's take an example of your project. So when you do the reviews, you kind of do code review, design review, UT review, your dev IT review, or any of the testing reviews, test cases review. So all these components are you are doing so as to avoid the failure in future. So all these is a component of prevention cost plus the appraisal cost. And appraisal cost also includes the audits. You do your audits for a project so as to get the CMMI level, maturity level, ML4, 5, or maybe some other parameter. So all these costs which are which you do to avoid the failure in future. You are spending the money in present to avoid the failure in future. So that is prevention cost and appraisal cost. And once you still have a defect, suppose in your reviews you didn't find any defect, and in the system testing phase or probably at the production you found a defect. So that is not in your hands. That is an escape defect because it has crossed all the phases of your project and reached to the production. So when you fix that particular defect, it is the money spent during and after the project because of failure. So that are internal failure cost or the external failure cost. So that will include probably rework, liabilities, warranty work, maybe business loss. Your customer will take the services or the contract from you. So these all is a combination of cost of non-conformance, and the previous which I had talked about is the cost of conformance. So the addition of two is equals to the cost of quality. So when you talk about in a nutshell, the cost of quality will be equal to the review, the time or the money you spend over the reviews, and probably at the end stage when you have the actual defects, which is optional definitely. If you have the good reviews and the good processes in place, then definitely your objective is to have the minimum number of defects which are at the escape defects, or you can say the defects which are on the production or at the customer premises. Moving on to the next slide, we have frequent verification and validation. So what exactly this terms means? Verification and validation in Agile is happen through effective communication, which I talked about. So you verify it and you validate it. So what are the modes of communication, or you can say the mechanisms in which we have proven that verification and validation are done? So generally they are as daily stand-up meetings, which are 15 minutes meeting, then frequent demos, release planning, iterative or sprint plannings, then retrospective meetings. So all these meetings in which you verify and you finally validate. So what exactly you do it's a 5 component process, which includes plan, verify, then you take the corresponding actions, then you again validate and correct, and again go to the planning phase. So it's a cycle: plan, verify, actions, validate, and correct. Although you don't need to remember from your exam perspective what is this combination of 5 components, you just keep in mind what are the mechanisms or the ceremonies in Agile or Scrum which do or which fulfills the purpose of verification and validation. So these are daily stand-up meetings, frequent demos. You do the demos frequently, maybe depending on your iteration. So it is the release planning, iteration planning, release review meetings, iteration review meetings, retrospective meeting, and so on. All the ceremonies which are involved in Scrum or the Agile world. The next topic we have in our slide is test-driven development, which is popularly known as TDD. So what exactly is TDD? It's a software development process, again a component of or you can say one of the methodology in Agile. So that relies on the repetition of very short development cycle. So what exactly you do in TDD? Instead of writing the code first, you do the test, you write the testing first. So write a test that fails. So suppose example, I don't have anything in my bucket of code. I have one objective XYZ. So instead of writing the code for that particular objective XYZ, I first write a test. So what all parameters will include in XYZ, how things will work, what all inputs will be there, what are the output parameters. So you write the test case first. So now in traditional, what exactly you do? You do the coding, then you do the testing, and then you do the actual testing. Do the coding, or the test cases can be written parallelly or sequentially, and finally you do the testing. But here in TDD, you write the test case first, in keeping in mind that it will fail because you don't have the code for that. Then you do the coding, to make sure that you do only the coding that is required to pass that particular test cases. So kind of a limited code. And finally, the third stage is eliminate redundancy, which is refactoring. So you can see it's a kind of a colored image, which is red for write a test case that fails synchronize with red, then make the code working is equals to green, then refactor, which is redundancy, maybe purple or any other color. So these are the prime driven factors for TDD, which is test driven development. So what exactly you do in a nutshell? First, the developer writes an initially failing automated test case that defines a desired improvement or new functionality, then produces the minimum amount of code, mark the word minimum amount of code, to pass that particular test case, and then finally refactor, kind of an normalization or the optimization of new code to have the probably standards or the efficiency or any parameter which is the objective for the organization or even for the project. So just to add on, test driven development is related to the test first programming concepts of extreme programming, which started in year approximately 1999. So just for perspective of examination, keep in mind red, green, refactor, which is write a test case, then make the code work and eliminate redundancy. These all is the mantra for test driven development. So red, green, refactor, red, green, refactor. Now moving on to the next slide, we have continuous integration. So as you can easily identify the meaning of continuous integration, you integrate the things continuously. So this is the prime definition of continuous integration. You do the integration of what? Your code, your design, your anything, actually code is the prime component for continuous. You do the coding, you integrate it, then you test it. It's a kind of a gradual process. So what exactly do you do a development practice that requires developers to integrate code into a shared repository. So probably shared repository can be any shared repository which fulfills all the criteria for the configuration management several times a day. So each check-in is then verified by an automated build, allowing teams to detect probably problems early. So you integrate it, you identify the problems early. So you don't have to wait that your code is ready, your iteration 1 is ready, 2 is ready, 3 is ready, but you do the integration at the end. Instead of waiting till the end, you do the integration. Just to reiterate myself, instead of iteration 1, 2, let's take an example of within iteration 1, suppose you have 10 tasks. So instead of integrating your code of task 1, 2, 3 at the end of iteration 1, rather you are integrating your code once it has been completed and tested. So you have an build, you need, what exactly you need to do this? An automated build. So if you see this graph, image, then we have sprint backlog at the center. Then we do the daily build, daily stand-up meetings, then continuous integration or check-in, then finally the acceptance testing, deploy to the laboratory or to any production environment or the pre-production environment, then finally the daily build, and finally what exactly you do? You have a potentially shippable increment, which is a product. So check in, then verify by an automated build, allowing teams to detect problems at the early stage. One of the another topic is definition of done, which you will found almost in your examination multiple times. So DoD is a collection of valuable deliverables required to produce software. So by the term you can identify it easily. What is the definition of done? When you say your iteration 1 is done, iteration 2 is done, so you should define a definition against any of your task, any component or iteration, sprint, anything, that what exactly you mean by done when you say done. So you need to identify and convey it to the right stakeholders that what is my definition of done. So when I say done, that means I have completed the design phase, I have done the coding phase, I have done the testing, and my code is ready at the production. So this is what the definition of done. And maybe for someone else, the definition of done might be only till the coding phase and the testing phase, not at the deployment at the production. So it depends and vary from finally product owner to product owner. So the client is the final responsibility who defines the definition of the done, and it's a mutual agreement. It's a bilateral agreement between the development team and the product owner. So definition of done is a collective collection of valuable deliverables required to produce software that adds verifiable demonstrable addition of value to the product and are part of definition of done, such as writing code comments, unit testing, integration testing, release notes, design documents, audits, blah, 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 blah. Then the third parameter is definition of done helps frame our thinking to identify deliverables that a team has to complete in order to build a software. So team is aware that what is my definition of done. So they can't say that my project, my component is 100% complete, even though they are in the coding stage only. So they know that all these parameters is finally a sum of all these parameters is my definition of done. So when I say done, so all my phases are completed, irrespective whether I am in a design phase, coding phase, testing phase, or anything. So focusing on value-added steps allow the team to eliminate wasteful activities. So definitely, you eliminate the waste when you have the definition of done. You don't do the irrelevant tasks which are not fruitful or not as a significant addition to your definition of done. Example, your definition of done is not talking about the documentation. Then why to document it? It's in kind of a waste. So your prime objective should be eliminate waste, which is again a methodology from Lean. So all these are interrelated. Again, so it is a simple list of valuable deliverables. You can say just a checklist. So that A, B, C, D, E, F, G, I need to complete all A to G so as to mark my component or a task or an iteration or a work product as done. That is DOD, definition of done. So DOD is the primary reporting mechanism for team members, and it is an auditable checklist, which I said earlier. So once you have the definition of done, then Agile Acceptance Criteria is another condition, you can say, that a software product must satisfy to be accepted by a user. So acceptance criteria is given by the end user or the customer, or other in the case of a system level functionality, that the consuming system, you can say. So acceptance criteria are a set of statements, each with a clear pass or a fail result. They don't have an ambiguity in between. So either yes or no. That specifically both functional and non-functional requirements, and are applicable at the epic level, feature level, and even the story level. So acceptance criteria constitute our definition of done. So they are interrelated. So what you define in the definition of done should be the acceptance criteria for your end user or the customer. There is no partial acceptance. So either it is yes or no. I have accepted it, I have not accepted it. So it is okay or not okay. As a user of the library catalog, this is just an example. I want advanced search option on the front page so that I can quickly and easily refine my search. So this is my acceptance criteria. So as you can see, it's well understandable. So what exactly is the parameter to write a good acceptance criteria? It should be in a simple language that the customer would use, just like the user story. We had talked about user stories in our earlier module. So it's just related to that, a simple language. So few of the examples are, I can limit the search by format or a type. I can delineate the search by date range. I can limit. So these are all the examples so as to have the acceptance criteria. So once you have fulfilled all these things in this example, then definitely your product is acceptable. Moving on to the next slide, we have feedback techniques for a product. So these are the feedback mechanisms. So what exactly you do, it's a general feedback. So feedback may be negative or a positive, maybe for a product, for an iteration, for an individual. But for individual, we don't do the feedbacks in Agile. It's only at the product level. So ask what exactly you want to do and you have to do, then review it and then follow up. So these are the feedback mechanisms. So effective software developers solicit and respond to feedback about software while creating it. So you create the feedback mechanism itself while having the software preparation. So software shared by feedback is invariably better received, simpler to use, and ultimately fares better in App Store ranking. Definitely you now in the world of mobile, you have the App Store, Google Store, so you definitely have, once you have the proper feedbacks, your rating will ultimately shoot to high. So all this is a mechanism of, again, a simple common methodology techniques of a feedback, but definitely it's been implemented, or you can say plugged in between the agile. So deep insights may be earned simply by showing your work, talking to users, or measuring what happens with software when it's actually used. Feedback is fundamental in yielding well-designed products from creative processes. So few of the examples of the feedback techniques in Agile or Scrum is daily stand-up meetings, sprint planning meetings, sprint review meetings, retrospectives, iteration demos, all kind of demos, even iteration and release planning and meetings. So all these plug into the talk about the feedback techniques for a product. In next slide we have CIP, which is continual improvement process. So in continuous improvement cycle, what exactly you do? First you define it, then model it, simulate, deploy, execute. Then what do? You monitor it, analyze it, and optimize it. Then again redefine. So it's a kind of a cycle. So that is a continuous improvement life cycle, or you can say continual improvement process. So it's a, you can say, is an ongoing effort to improve products, services, or processes. So in nutshell, you define it, and finally you optimize it to again redefine it. So in between these phases, you model, you simulate, you deploy, execute, monitor, and after monitor, you definitely do the analysis also. So these efforts can seek incremental improvement over time to breakthrough improvements all at once. So this all will improve your quality of your product or the services. If you do this kind of an cycle, you follow this life cycle. Then we have a PDCA cycle, again a kind of a more US based, or you can say the geography based. If you talk about, it's a PMI group keywords, which is PDCA, which you recall them as plan, do, C for check, and A again talks about act. So first you do the planning. So establish the objectives and processes necessary to deliver a result. That is all your KPIs, key performance indicators. Then you call to action. That is your do. Actually you are doing it. That is action, implementation. So you implement it against your plan, execute, and collect data. So once you have the data, you check it. You kind of do the study to have the actual results, or kind of an analysis. Then you again act. Maybe you have to act it positively because your all processes are fine, or maybe negatively, your processes are not well fine. You need to act it in another way, so as to redesign it. So all this are again a component of an immediate feedback. So this all is a data collection. You call to action, you immediate feedback, data collection, analysis, and again redesign. So plan, do, check, and act. In the next slide, we have the balanced scorecard. So as the name suggests, it strives to strike a balance between the various performance measures. So you need to, suppose your key performance indicators are defect density, effect variance, productivity. So you need to have a balanced scorecard so that your all these key KPIs will be in balance. That is, there are no either too much of a positive variation or neither too much of a negative variation in between them. So balanced scorecard allows managers to view the company from several perspectives at once. So maybe it is in terms of financial, it is objectives, measures, targets, or initiatives. And if you business processes, then again it's targets, initiatives. Then we have learning and growth also curves might be possible. Customer, strategy, all these are the components of a balanced scorecard. Though this is not important from the perspective of examination, but definitely you should be aware of these stuff, because you can see few of the keywords in your examination and few of the questions. When we talk about the quality, definitely we can't miss the term Six Sigma, which is DMAIC. When we talk about DMAIC, so it refers to define, measure, analyze, improve, and finally control. So again, you can relate it with that PDCA, which we have done it earlier. That is plan, do, check, and act. So again, this is a more split up. But it's a different organization, you can say Six Sigma. So we have a different terminology. Define, measure, and all these terms do the same stuff. So DMAIC refers to a data-driven improvement cycle used for improving or optimizing and stabilizing business process and design. So is the core tool used to drive Six Sigma project. And however, DMIC is not exclusive to Six Sigma and can be used for the various framework for the other improvement applications. So what exactly you do in define? You define the project purpose and scope, identify high level of process for improvements, determine customer needs and benefits. Then comes the second stage of measure, in which we do the baseline data on current processes. You can say pinpoint problems to locations and occurrences, identify potential areas for improvements. Then you do the analysis, in which you do the root cause analysis or identify the gaps against the measure. Then you do the improvement against your analysis. That is what exactly you have, you do an action against your root cause analysis. And finally, you have a control mechanism to perform before and after analysis, monitor systems, document result, and determine next step recommendations. So all these are talk about of a Six Sigma, that is DMAIC, which is define, measure, analyze, improve, and control. From the perspective of Agile, Kaizen is the very important keyword, which is continuous improvement. So when you translate this Japanese word Kaizen, it comes to continuous improvement. And for continuous improvement, we have just talked about it in the previous slide. So you split the word Kai is equals to change and Zen is equals to good. So you do the change for good. So that is a continuous improvement. Quickly talking about Kanban, flow, and cadence. So Kanban, again, I had said in my earlier modules also that it is again a Japanese term for the visual board. So Kanban system is a mechanism for controlling the work in a software development system. It displays the upstream and then downstreams of work, or enables full system, which is like just in time. You have the flow, which is effective work. Flow describes how the work in the system can deliver maximum value. And cadence is just as English synonym for the word rhythm. Rhythm is, you can say, rhythm is just like in a musical note, you have a rhythm, you have a consistency of time boxed. So that is a cadence. You do the cadence is the approach to achieving commitment and reliability with the Kanban system. So you just have to keep in mind that throughput is equals to WIP, which is work in progress, divided by the cycle time. So cycle time is the actual time which you do, which you have spent to do the actual work, not the interferences in between or kind of resonances in between. At the end, we have few tools for the continuous improvement, for which I have merged my slide into two parts. One is this one, in which we are talking about benchmarking, control charts, affinity diagrams, force field analysis, quality checklists, and finally process improvement plan. So when you talk about the control charts, it's just we have a lower control limit, we have an upper control limit. You plot a graph against your X or Y axis, where X is the time and Y is any component, probably effort or number of stories. And you find you identify the outliers in between. So outliers can be which is below the LCL or maybe above the UCL. So you have a mean in between, and based on that you do the analysis. So this is the kind of a tools to do the continuous improvement. So you monitor these control charts regularly, and you do an improvement against those so as to make your graph smooth. You do the benchmarking. It's very simple from the word itself. You do the affinity diagrams, that is this mentioned in the right hand side of the slide, that you do plot the diagrams, affinity diagrams. Then we do the quality checklist. You can prepare the checklist in advance. The one tool is force field analysis, where we have the driving force, you can see the positives ones at the left hand side, and at the right hand side we have the negative, which is called a restraining force, which is taking you towards not doing the final product. So issues or changes that are changed under the study. So these are few of the tools for the continuous improvement. few more in the list are causal and effect diagrams, which you talk about the fishbone diagrams or the Ishikawa's diagram. Then we have the Pareto charts, that is the 80-20 rule. Then the histograms, run charts, influence diagrams, SWOT, that is kind of a self-assessment, and wisdom of crowd. So all this is, so SWOT is, you are commonly aware, that strength, weakness, opportunities and threats. Pareto, you plot a histogram in bar graph, in fact, to identify the Pareto parameters, which are, you can see the 80% of the defects are because of some prime reasons. So those prime reasons will come into the Pareto chart. Then you do the influence diagrams and so on. So these are kind of the few tools for the continuous improvement. So that's all for today in my bucket for you guys for the product quality. Thank you very much for your time. Have a good day. Bye-bye.